All right, well, welcome to the Implementing Machine Learning on the Edge with ModusToolbox, Picovoice, and SensiML webinar. In today's webinar, you'll get a brief intro to ModusToolbox and learn how you can use Picovoice and SensiML to create innovative ML projects with the power of Edge AI. So you'll notice we've got several speakers joining us today. We've got Danny Watson, a principal software product marketing manager from Infineon, Huya Rostam, an embedded lead at Picovoice, Eric McCoolin, a software engineer at Picovoice, and Chris Norowski, a co-founder and the CTO of SensiML. You'll also see a couple other people. We've got Nicholas Sharp from Infineon, Dalek Karasoy from Picovoice, and Asang Purchi from SensiML here to help answer questions throughout the event. So you may see them pop up in the Q&A or the chat today. So a little bit about the event today. The first part of today's webinar will include a presentation followed by a couple of demos, and then we'll have about 10 minutes for you to ask your questions and presenters will answer those. So if you have questions during the presentation, please write them in the Q&A section at the bottom of your screen, and our presenters will answer as many of those as they can before the end of the session. So thanks again for joining us, and I'm going to let Danny get us started.
Hi, thank you, and welcome all with this. So a little bit of an agenda. We're going to go through the prerequisites before you can get started with much of these demonstrations. And then we'll be handing it over to the Picovoice team to show you their platform and how to use the PSOC 6 with it to get you started. And then we'll be passing you over to the SensiML, which will be Chris, to learn how to use the SensiML platform for general machine learning use cases. And then to finish off, we'll be briefly just going over some slides on how to use our ModusToolbox ML tool. Right, so some of the prerequisites, it's assumed that you have installed ModusToolbox itself. ModusToolbox is a full infrastructure for you to be able to take code examples, middleware, and build your own software in a way that is suiting your specific use cases. We have support for multitudes of IDEs. And it's assumed that you will either use the Eclipse IDE that we provide or one of the other supporting IDEs like Visual Studio Code, IAR. There is a user guide as well that can tell you how to use these IDEs. And it's also assumed as well that you have a Picovoice free tier account or a SensiML free plan account as well. So without further ado, I'm going to hand you over to the Picovoice team for them to go through their platform and running it on the PSOC 6.
Thanks, Danny. Yeah, so my name is Eric. I'm a software developer here at Picovoice. And briefly put, Picovoice is an end-to-end voice platform for building voice experiences on your terms. You can see we have a variety of different products covering a broad range of voice interactions, speech to text, voice activity, voice search, speech to intent. But today we'll be focusing mainly on Porcupine and Rhino, which is what we call our wake word and speech to intent engines, respectively. How do Porcupine and Rhino differentiate, and what is a wake word and what is speech to intent? So if you think about voice interactions, there's sort of two parts. So you can imagine you have your phone and you might say something like, hey, Google, send this message for me. So there's that initial part, that hey, Google, that wakes up the device and lets it know that you want it to do something. And then there's your command, send this message for me. So in Picovoice, that initial part is handled by Porcupine. That is your wake word, hey, Alexa, hey, Google, hey, Siri. And Rhino handles that follow-on command. So let's get right into the live demo. I'm going to show you how to quickly get up and started using ModusToolbox and a PSOC 6 board and Picovoice. So I'm going to share my screen. So we should all be able to see the Eclipse IDE for ModusToolbox. And I'm going to go down right here into this quick panel and just hit new application. It's going to just update the latest boards and templates. I'm going to hit a PSOC 6 board because that's what I have with me here today. And this is where the project templates are. I'm just going to type in Picovoice. And you can see there's two demos under the voice tab here. There's the Porcupine wake word demo, which is just Porcupine standalone. and what we call the Picovoice end-to-end voice recognition demo, which is both Porcupine and Rhino working together on the same board. So normally you'd click this and hit create, but in the interest of time, I already done that. So I'm just going to close this window. So you're going to get greeted by the project README, but before we do that, I'm going to go over to the main file here. The main file here and copy and paste my access key in. So the access key is required to use all of our Picovoice SDKs. They're free to get. You just have to sign up for our console and click the show access key button, and I'll show you, that'll be shown again later. So, but once you've put that in, you should be able to hit the program button and program your board. So while that's downloading, I'm going to just explain sort of what the context of the demo is. So it's kind of like a smart lighting solution. So the wake word is, of course, Picovoice. And then the context for the follow-on commands is all sorts of smart lighting stuff. So you might be able to say like, turn on the living room lights or set the kitchen lights to red or something like that. So the board has been programmed. So I'm just going to switch over to a serial monitor here. I'm going to reset the board and I'm going to give it my command. So Picovoice, turn the kitchen lights off. So we can see it understood the wake word and then printed out the following command that it understood. We can see that it said change the light state was the intent in the kitchen and turn them off. So we can say Picovoice, turn the pantry lights red. And we get the same thing. So wake word, it understood that our intent was to change the color in the pantry lights to red. So jumping back to the README here and the code, I just want to highlight a couple of things. So we do feature support for multiple different languages. There's English, French, German, and Spanish right now. And there's instructions on how to change that in the README here. And the other thing I'd like to highlight is the code. So the input into our engines are just these two callback functions here, which means the output or the actions that it takes can be whatever you want. So in the case of this demo, it's just printing to the serial console and changing the LED, but it could be, activating a motor or a coffee machine or whatever your product or project is. So that being said, let's say you did want to customize this and use it for your project or brand. I'm going to hand it over to my colleague, Puya, who is going to walk you through customizing it with a custom wake word and a custom context.
Thank you, Eric. Hello, everyone. I'm Puya. Let me first share my screen. Okay, great. Here we're going to create some bespoke models together. For that, you need to go to our website, Picovoice AI. And on top, there's a link to console. Click on that one. To use our console, you need to have a virtual account. So if you haven't created one, feel free to do that. Here on the left side, there's an access key. There's an access key box, and as Eric mentioned, you need to pass this access key to our engine to initialize it. It's pretty easy. You just need to copy it and then paste it in your ID. And so by now you should be familiar with our Porcupine and Rhino engine. Porcupine basically spot the utterance of a keyword, and Rhino just listen to the follow-on command and extract information from that. So for create a custom wake word, you need to go to the Porcupine section. If I click on that, you can see it's pretty easy. There's nothing here. You just need to come up with a good phrase that describes your application or your brand. So for this webinar, I think Hackster would be a good wake word, right? So you can select your language, English in this case, and platform. So for PSAC, because it's a microcontroller and it's ARM Cortex-M, you need to select that. And when you select ARM Cortex-M as a platform, the console is ask you for word type, which is PSOC. And there is one more additional thing, which is unique identifier. And actually, this is the first thing that board prints when you program the demo. So you will see, if you look at the serial monitor, this is the first thing that is printed out. So I just need to copy that and print it here. And if I'm happy with everything, I can go ahead and click on the train. The wake word is available to download right away. There's another cool feature of the console that you can test your wake word inside browser by using this mic widget. So if I say Hackster, 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 so you can see the performance of the wake word, and if you're happy with that, we can move on to the next section, which is, let me also download this part. Okay, so the model is downloaded. We will go back to that later. So Rhino, for Rhino, you need to create a document first. And if it's your first time working with the Rhino Editor, I suggest you to start off with one of the templates because it's giving you some idea how to work with the editor. So for this demo, I go with generous coffee maker, and you will find out why I selected this name in a minute. It's Rhino Editor, right? There's this doc. In this doc, we have just one intent, which is order beverage, and inside the intent we have a couple of expressions. And expressions are basically all the possible ways that you can convey the meaning of that intent to the Rhino engine. Let's say we want to add a new feature to our coffee maker to also donate a beverage if we want it to do. So we can create a donate beverage intent. If I click on that, you will see that the expression is empty because it's a new intent, and we can say, okay, please, if I can type correctly, please donate a coffee. And after that, I can save, and similar to Porcupine, we can test our model here inside the browser. So we need to wait a little bit. Please donate a coffee. Okay, great. So it gets the intent, but there's no further information. And also, it's not a very smart way to do it because let's say I want to also donate something else. I need to add another expression. So in this case, we can do a little bit more smart here and use slots, which is our variables. So if you go to beverage, you can see all elements in the slots. So we can say beverage, and it will cover all these elements. So let's add chai to the list of beverage, and here instead of coffee, we can say, okay, we want to donate a beverage, and the name of that beverage or that variable can be donation. So if I save that, train it again. Please donate a beverage. Oh, sorry. Please donate a coffee. Okay, so now the intent is donate beverage and donation is coffee. I can also say, please donate a chai. So you can go back and forth between adding expression, testing it, and if you're happy with the performance, you can easily train on, click on the train button. So the training part is similar to Porcupine. Select ARM Cortex-M, PSOC, and a unique ID. And the model is training. The model is available for download right away. So we need to download that again. So let's go back to our download folder. So you can see the download models are in zip file. If I extract one of them, you will see there is 2 files. One of them is the binary format of the wake word or the context model, which is pretty small. For user convenience, we also added a header file with the models in C array format. And so here you can see it's a context array, and this is basically the model that we trained just now in console. So you need to copy this array and then go to the IDE. In the project tree, inside the include folder, there's a PV_param header file. And inside the PV_param header file, for each language, you will see 2 arrays: keyword array, which is the wake word model in C array format, and another context array. So if I want to replace the smart lighting context, I can just select this part. Select this part and replace it with the new one. I think that's it. I already replaced the wake word, so I need to compile it again. And program the word. And while the board is being programmed, I want to show you something. Yeah, I want to show you some documentation for microcontroller. So if you go to Picovoice website, go to the doc. For each product, there's a section. For Picovoice, we have 2 main docs. One of them is Quick Start. If you find the microcontroller here, you will see there is a step-by-step tutorial, and it's basically what Eric and I have done so far in this seminar. So it helps you to get a start pretty quickly and work with console and the IDE. And there's another documentation for API. So if you are more interested in knowing the details of the function, how to work with Picovoice API and how to customize it, I highly suggested you to take a look at this part. Okay, I think the board is programmed, so I can say, Hackster, please donate a chai. Okay, now we have our custom wake word, which is Hackster, and the custom context, which is for donation, and our newest slide, which is chai. I also want to introduce some additional resources. One of them is our online demos, so you can find them on our website. They're pretty fun to play with, and it's also give you some idea how to create your context and how to use our Picovoice platform. And the other one is that we are pretty transparent about our products, about the performance of our product, and that's why you can find a benchmark for each product on our GitHub, and they're open source, and you can run them yourself and basically get the same result. So I think this wraps up the Picovoice part. I'm going to pass the torch to Chris from SensiML.
Thank you. Excellent. I'm just going to go back and share my screen, and then we'll hand it over to Chris from SensiML. And just for your information, there's also some additional information as well on the Picovoice side for you to go and look further into. Okay, now I'm going to hand it over to Chris Norski to go through the SensiML platform.
Okay, thanks. Yeah, thanks. That was a great presentation from Picovoice too. So SensiML is a a general purpose machine learning platform, which you can use for analyzing any sort of sensor data, whether it's IMU data or environmental sensor data or audio data. And so we came out of a team at Intel that was focused on the Intel Quark and Curie. And right now we have a sales channel, established partners, which Infineon is one of them, as well as a sales support that can help you across different time zones. And so SensiML provides a full AI workflow for dataset creation and testing. It's not just an AI modeling engine, and it's designed for multidisciplinary teams. So you can have lots of people from different areas all working on the same data sets and building models against the same data set within our platform. And so we see within our customer base kind of a broad use cases that are starting to emerge in different areas such as industrial, consumer, and commercial. Some of the areas that we're really excited about right now are around the predictive maintenance, where you're looking at different faults in monitoring. We're seeing a lot of interest in the smart goods, which is around activity detection and monitoring, especially in elderly care, as well as in the smart infrastructure around animal monitoring, as well as different sorts of smart home use cases. And so the SensiML workflow consists of a data capture lab, which is for collecting and annotating sensor data, which is key to building really, really good machine learning models, especially when you don't have data sets readily available that you can use to train your models against. The next step is the Analytics Studio, which helps you to build models from that sensor data. So once you have collected sensor data and annotated it, you can go into the Analytics Studio, where at that point you can select from a variety of different machine learning algorithms and feature extractors to build a machine learning pipeline. You can use our SensiML AutoML, you can use custom training, and you can also go into a Python programming language to build out pipelines programmatically. And then finally, we have a number of different applications to help you test on device, whether that's streaming data to the data capture lab to test the model live before you flash, or graphical UIs using the Open Gateway to view the results in real time and record that. So now I want to go ahead and show you the application running on the PSOC 6. And so I'll go ahead and share my screen. Okay. So today I want to walk you through a demo with SensiML, and to do that demo, we're going to use the guitar note audio recognition example. So if you go to our documentation at sensiml.com/documentation, and you click on guitar note audio recognition, you'll see the entire tutorial. And so what we're going to do here is audio classification for 6 guitar notes that we're going to identify. And so to start with, first we need to start with the data collection firmware. And for that, we're going to use the ModusToolbox. So if you click on new applications, and we go to the PSOC 6, click next, and then under, and then under machine learning, you'll see the SensiML template firmware. You can click that checkbox and click create, which will create the machine learning application and set everything up for you. And so I've already created the application here, so I'm just going to go ahead and point out a couple of things. So inside the source folder, you'll see a app config. And this is one of the key files that we use. So the firmware is configured to, initially in data collection mode. So we have 2 different modes, so data capture running mode and recognition running mode. So when the firmware is in data capture running mode, it's going to be, it's ready to stream sensor data out. And when it's in recognition mode, it's going to send that sensor data to a machine learning model. So the first thing you'll want to do is you want to set the application mode. So I've set it to data capture. And then you want to decide what sort of application you want to build. So we've already created the firmware for collecting IMU data as well as audio data. So in this case, I'm going to collect sensor audio data. So in the sensor select mode, I set it to sensor audio data. And what that's going to do is configure the board to collect sensor data. So then, oops. So if we go to the README file, there's instructions for how to get up and running. And then when you're ready to build and flash the program, you can run the make command or click the build screen. So I'm not going to go ahead and run that right now, but you can go to the terminal for your application and paste this in, and this will flash the board with the data collection firmware. So I've already done that before we started this project. So the first thing I'm going to do is open up the SensiML Data Capture Lab. So if I click on open the Data Capture Lab, and you can log into your account, and I'm going to open up this guitar tuning project. And if you follow along in the documentation, this project is already loaded up there. You can download that project and import it into your version of the Data Capture Lab. So the first thing I'll do is I'll click on the Project Explorer. And what this is showing is all of the files that we've collected for this project so far. And I'll go ahead and collect one file really fast just to show you how it is. So we'll switch over to capture mode. And in capture mode, I can come down here and come to connection settings and click scan, which pulls up the COM3 port where the PSOC 6 is connected. When I click done, and then I can hit connect. And what this will do is start connecting to the PSOC 6, which is now streaming audio data. At this point, you're ready to start collecting data. So up in the top right, what we have is a number of different the file name. So in this case, I'll name this guitar notes, and you can add any number of different metadata that you'd like to this project. And for this demo, to make it easy for everyone to follow along, we're just going to use a YouTube video that's playing guitar notes. So as I play the notes, you can see it on the screen, and I'll go ahead and click start recording and just record 2 of those notes. Okay. And then when I hit stop recording, it pops you up with a confirmation screen where you can edit any of these fields. If maybe you had named the file wrong, so you can rename it, and then you can hit save, which will automatically upload this file to your project. So if I click over here on Project Explorer, now I have the guitar notes WAV file that we just collected. I can go open it up and begin editing this file. I'll switch over to one that we've already labeled that has the full annotated data set. So I click here and I open up this file, which brings up a data set that I recorded prior to this meeting. And you can see in here that there's different markers, and these markers mark the regions of the data set that we're interested in classifying. So this first marker right here, you can click and add new markers by right-clicking and dragging, and then you can edit that marker and assign a specific label to it. So in this case, I've gone through and I've labeled this entire file with the different notes that are in the guitar tuning classification example. So over here on the top right is the segment explorer. So the first 2 notes are E, the second 2 notes are A, D, G, B, and E1. Oftentimes when you build a machine learning model, you want to have a train and test set. So in the metadata explorer, one thing we can do is we can come into our metadata and we can click, we can edit the metadata, and we can set specific files to be either in our test and train set. That way, when we go to build our model, we can pull in only data from our train set so that we have some held out data to test against later. Another thing that I went ahead and collected was just some talking noise. And we can use this to train the model to reject talking noise when we go to build it. So I recorded some instances of me talking, and then I can come into this file. And again, I just mark this region and I come and hit the edit and I label this one as talking. Now, when I go to build my model, it'll not only just classify the different guitar notes, but when it identifies talking, it'll use that, which will improve the overall experience for the end users. So now that we've built our entire training data set, the next thing we want to do is go build a model. So let me open up the Analytics Studio. And the first thing when you sign into the Analytics Studio, if you haven't created an account yet, you can click on the Start My Free Trial and sign up for a free account, and that'll give you access to all of this software. And I've already signed in right here. So when you open up the Analytics Studio, you'll see a list of all of the projects that you have. I'm going to go ahead and open up the guitar tuning classification project that we were just working on. This overview screen shows you all of the different captures that you have in your project. It shows you the different queries that you have in your project, the pipelines, and the knowledge backs. So first, we'll start with queries. So for this project, I've already created a couple of queries, and I will open one up and explain what that is. So the query describes what sort of training data do you want to pull into your model. In this case, we'd like to pull in all of the data from our training data set. And so I can come here and I can adjust the, so we want to pull in our training data. So here we've created the session, the label, the metadata that we'd like to attach, as well as our source channel. So in this case, we only have a single microphone channel, so that's what we're pulling in here. And on the right side, we see all of the a summary of all of the segments that we have as part of this data set. So this tells me I have eight segments of A, 8 segments of B. All of these, this is a well-balanced data set, as well as I have 6 segments of me talking. And you can also switch and see how many samples you have of each. So segments aren't necessarily indicative of how much data you have. So in this case, I have 20,000 samples from example A, and I have a little bit more talking data than I do for the individual notes. If you want, you can go in and add additional metadata. So if I were to add set here, I could come in to my query filter, select set, and I could specify only the train set. And what that would do is only pull in the training data to my model. The next thing we want to do is go to the build model. In the build model screen, you can see previously built pipelines that you have, and you can open those up, or you can start building a new pipeline. If I click build model right here, I can enter a pipeline name, and I can select to use either the AutoML, or I can build a custom pipeline if I know the specific type of classification algorithm that I'd like to use. Since I've already created a pipeline, in the interest of time, I'm just going to go ahead and open that up, and I'll walk through it. So when you click on the pipeline, there's 2 views. One is the simple view, which just shows you the input data, the type of segmentation that you're using, and then the AutoML parameters. If you click on this button here, it expands it out, and you can see all of the individual steps that are in the pipeline. So the first step here is the query step, and this is telling me which query I'm using as input into my model. The next step is windowing. So when you're building an algorithm to run on the device, you have to decide how you'd like to segment that data to feed it to the classifier. So in this case, we're using a sliding window, and the window size is 400 samples. The next thing we're adding is a segment energy threshold, and you can we set the energy threshold to be 275. What that will do is reject any noise below that threshold. The next step for our pipeline is to add feature generators. And so the feature generators that we have for this pipeline right now are the MFCC, which you can expand out and modify those parameters, as well as the rate of change. For different applications, typically you'd like to add different feature generators. So we have a lot of feature generators built into the pipeline. You can click on the plus feature generator button here. You can expand each of these out to see the different feature generators that are available in the toolkit. And to add them, you can simply click the plus here. You can come in and edit any parameters that you want and click add. And now these show up as part of the feature generators that will be created for your model. I'm gonna go ahead and cancel that. The next thing we want to do in this model is we want to add a feature cascade transform. And so what that's going to do is it's going to combine multiple windows together. So for the audio model, what we're doing is taking a window size of 400, computing features from it, and then we're going to stack multiple features from consecutive windows together. And that's what this feature cascade transform does. And so you can come in here and set the feature cascade to whichever size you'd like. And that size will be the total number of cascades times window size will be the total amount of data that is fed into your machine learning algorithm. We have a couple of other steps. So we have the min-max scale quantization and the feature selector step. So the feature selector, we add a couple of different feature selectors into this pipeline. So correlation threshold, variance threshold, and information gain. And that's going to allow us to pare down the number of features that we use on the device. Typically for embedded platforms, the less features you can use, the better. So you want to be very cognizant about which features you're using. So this will help us reduce latency as well as the model size. And then the final step of this pipeline is the classifier step. So in this case, we're using TensorFlow, a TensorFlow model. We're training a fully connected neural network. And then we specify what type of validation method we would like to use. You can select from a number of different validation methods. In this case, I'm using stratified shuffle split, but you can select from a number of different ones to help you tune your search space. The final step is to click optimize, which will kick off the machine learning pipeline job on the server. And that will go through and pull in your data, extract, run all of that data through each of these individual steps and train a number of models. In this case, I've already done that, so I'm not going to click it again. And what will happen is it will either return 1 up to 5 models. In this case, it's returning a single model. And I can go and click on this model to see exactly what's happening here. So the first page shows a model visualization screen. And in this visualization screen, you can see which features have been chosen and what the feature distribution looks like for that. So you can get a 2D view of the individual features. You can go look at the confusion matrix to see how the model performed across individual folds, as well as the final training data. And you can go look at the feature summary to see a really in-depth view of all of the features that are selected as part of the model. We also have a model summary, which gives you details about how the model performed as it was training. A pipeline summary, which stores the history of how this model was trained. And the knowledge pack summary, which tells you which steps will actually be put onto the final device. Once you're happy with your model, you can come to the test model screen, where here you can test the model against captured files. So typically what you would do here is you would come and test it against data that was in your test set. And it'll give you a score and a classification accuracy for that file. And then finally, when we're happy with our model, we can come and download the model directly. So in this case, you can come and select the hardware platform for the PSOC 6. You can select the library format and then the library or source format. And then the PSOC 6 audio capture is our data source, which tells it how to configure the sensors when we download the library. And then you can go ahead and click the download button, which will start downloading the firmware. So I've actually already done that right here, which will be ready to flash onto the device. So before I flash it onto the device, I'm going to jump back over to the data capture lab in the interest of time, just so I can test the model out. So if I click connect here, and again, we're just going to start streaming data into the data capture lab. Oops. The gain is messed up. Okay, that looks better. So we have another mode in the data capture lab, which lets you test the models in real time. So here I can come into the test model tab. I can select the knowledge pack. So here's a knowledge pack that we just trained, or I just trained right before this meeting, which is guitar note with talking rejection. And you can download that model and then run it in real time. So now if I click connect on the knowledge pack, and I come over to play our Google file again. What you're seeing is the classification that this model has in real time, and you can see it's also picking up when it hears me talking. It'll label that as talking as well. Okay. So that walks us through all of the steps to build the model and then quickly start testing the model in real time using the Data Capture Labs live label mode. And we'll go ahead and disconnect that. And so one of the great things about this is you can record those examples as you're collecting it and go directly back into the Data Capture Lab and relabel the areas that were misclassified to help you augment your training data set and to build a better model. So the last step in our process is to go ahead and flash that knowledge pack. And so instructions for flashing the knowledge pack are included in this tutorial. So once you've downloaded the model, I'll just go ahead and open it up. So inside the model, you'll see a knowledge pack folder, which has the model.json, which is information, all the information about the model that was just downloaded. We have the SensiML, which includes a lib file. So here you'll see a libsensimal.a, which is our knowledge pack library, and the lib TensorFlow microlite, which is a TensorFlow library that's compiled specifically for this knowledge pack. So it's much smaller than a typical lib TensorFlow microlite A library that you might have. And so then the next steps are to copy these files over to our libs directory. Oops. And then we can build and flash the model. And then I think I'm kind of running out of time. So Danny, do I have time to go through that, or?
Well, I think what we might have is a specific a follow-on webinar where we can actually maybe go a little bit into that as well. So we do plan to have some Q&A webinar which we can go through that.
Okay, yeah. So
I think the information is in the README where they should be able to obviously take the existing example and update it.
Okay, then I'll go ahead and stop there for now. So yeah, so that's the SensiML Toolkit workflow. It's a general, like Danny said, it's a general purpose machine learning platform. So if you have any sort of time series sensor data, it'll help you to build an algorithm that will run efficiently on the PSOC 6 platform.
And then some additional information as well that's SensiML provided as well, where you can obviously sign up, go through the demonstration, and obviously the firmware documentation as well, on how you can then further flash the device. Okay, and then the final section is a presentation. So in regards to we have at Infineon have provided a ModusToolbox ML tool, which allows us to enable the expert mode, which if you are using the standard frameworks or you've got an existing Keras model that you want to deploy, we provide a workflow for you to go and deploy that onto the PSOC 6. So I'm going to quickly go over some slides on what we provide and some screenshots on how that tool is shown to be working. So as part of our ModusToolbox ML toolkit, we provide a bunch of features with a graphical UI for support for Keras H.5 files, where you can take that and run it through our tools and have features like device optimization, validation, and obviously it's all pre-integrated within our ModusToolbox ecosystem as well, allowing you to combine it with other code examples like our connectivity and utilize the Bluetooth, Wi-Fi connectivity options as well by using the library manager. So we provide our own inference engine, which the tool works with, which then allows you to deploy your models onto the device. What can you do with it? So like I mentioned, we have support for Keras style H5 files, and we support the kind of common layers like convolution 1D, 2D, and we also support RNN and GRU based frameworks. And then we also have support for 8-bit and 16-bit quantization. So you can actually then reduce your model sizes and improve the performance of your model. It allows you to also generate the code which integrates into the actual ModusToolbox project. So we actually have a specific machine learning project, a profiler and a gesture example of something that we've already run a gesture model through our framework and deployed as binary. And we provide obviously optimized libraries that's going to run on our hardware as well. So you get one of the best efficiencies running on our SoC. And we provide like I mentioned, the GUI and the tools to import the data for testing within the actual tool. So you can do testing actually within the GUI and obviously with data that you've provided rather than actually providing doing the testing on the device itself. So you can actually see when you do those quantizations to 8-bit, 16-bit, you can see what the performance is going to be like. And as mentioned, we have a template embedded project as well. So a little bit of detail of the graphical interface. You obviously have a pre-trained model which you can then import and deselect the framework, and it gives you all the cycle counts for the different in 16 by 16. And it also tells you what type of scratch memory and model memory that's needed to run it onto the device. So you can do some pre-testing and pre-understanding of what the model is going to look like from a cycle count. And then obviously as well from that H5 file format, you can then generate the source that then can be deployed onto the actual hardware as well, which then can be imported into the code example that we provide. We also have like a validation section here as well. So based on the quantization selected, you can see what the probability scoring of the different implementations, and you can import the samples for you to do that validation. And like I said, yep, you can run the validation on the tool. And it tells you obviously the error matrix as well, based on the quantization. So that's a brief introduction. We do plan on a following webinar to actually go into more details, which will be from Nicholas, who is actually answering a lot of the questions in the background. But we do have a more detailed webinar planned, which we'll be hosting in the Hackster discussion area. And the idea here is to, obviously we don't have enough time to go through everything, and we wanted to make sure that we have Picovoice and SensiML also shown on how to use their tools. Without that, I'll hand it over to the Hackster.
Awesome. Thank you, everyone. These were great presentations. One thing I did want to mention that I don't think has been talked about yet is that we do currently have a contest going on Hackster, Build AI for the IoT contest with Infineon. I believe Ginger just posted that link in the chat, but I'll make sure that that gets posted too, so you can go check that out if you haven't yet, if you're not familiar with it. And then I think we'll get started on some questions. A lot have already been answered. So if you do have questions, now's your chance to put your last minute questions into the Q&A. I think we're gonna start with the Picovoice team. Is there any questions that you'd like to go over that you got during the webinar today?
Yeah, there were a couple that we answered in text, but I'd like to highlight. One of them was someone was pointed out that the free tier for Picovoice has some limits, and how can he get those limits raised or changed? So first I'll highlight the limits. So the free tier lets you train 3 Porcupine models per month, and those limits are reset every month. And I think there's a similar amount for Rhino. I think it might be 10 for Rhino, but to get those limits changed, you just go to our pricing page or our contact page and contact sales to get a new plan or whatever works for your project.
There was also another question about the edge benefits over the cloud solution. So for that, I would say the first thing is like the basic thing is the experience, because first there's no latency in each solution, Picovoice compared to the cloud ones. The other one is privacy, so you don't need to like send over your voice to cloud to being processed. And the third one is the experience, developing experience, because we streamline the developer experience to shorten time to market. So this is also a good thing to point out here.
Awesome. Any other ones or? All right. Chris, did you have any that you wanted to address that had, I know a lot of them have been answered via text already, so.
Yeah, Isan, did you get a chance? I haven't gotten a chance to go through all of them yet, but
so there was a question about whether or not any part of SensiML is open source, or what kind of source codes they can get from SensiML.
Yeah, so we have our SensiML embedded SDK for our subscribers. It's completely open source, and so you'll be able to see all of the inference engine that we're using, and you can modify that to work with your specific device.
Any others on there, or should we move on to Infineon?
Were there any other questions, Isan?
No, there is another question for SensiML.
Okay. Awesome. All right, Danny, I know I saw a couple that you wanted to answer live, so I'll give that over to you.
So carrying on from SensiML, there was a question, where does SensiML and ModusToolbox complement each other? I think it's best for Infineon to answer that. The great thing that we've done, not just with SensiML, but also with Picovoice as well, is we've actually pre-integrated the code examples and the inferencing within ModusToolbox, and the benefit of that allows you to then move them over to different devices. However, they're not tested on different devices, but because they're actually within the ModusToolbox ecosystem, it allows you to then take those code examples and repurpose them to different BSPs. So that's one of the complements, is you can definitely split the dev flow, where you can go ahead and do all your platform-based development, and then you can go and deploy them within a code example that already exists, rather than obviously taking a code example or a bunch of source and you having to manually fit it together into an existing code example. So that's one of the benefits of the integration with SensiML and ModusToolbox, and obviously Picovoice and ModusToolbox as well. Another question was they have two boards and they'd like to communicate them via Bluetooth or Wi-Fi. And they was asking a recommendation on how to do this. So we within obviously Infineon have a very wide set of code examples on the connectivity side. Obviously, we're well versed and one of the leaders of wireless connectivity plus MCU. So with those two complements, we have a bunch of code examples. So you could go and do this communication via the AWS or Azure code examples, where you can connect to the cloud and you can start interacting via the cloud. Or we actually, I believe, have some code examples with Bluetooth and a Bluetooth mesh example as well, a gateway example that was released back in January, where you could take essentially a Bluetooth gateway example, and you could send messages via that way. The other option that you have is we do have HTTP client and HTTP server examples. So you could have one device which is actually got an HTTP server running and another device which is the HTTP client, and you could start sending messages via that way as well. And obviously the great thing as well is you could go into Library Manager and you could start importing the Picovoice example and integrate it, and obviously get that up and running as well and start sending those messages over to say that things have happened. So I hope that answered that question.
Awesome. I think we had one, Picovoice wanted to answer one
Yep.
other one, the last one we've got here.
Yeah, so someone asked, can Picovoice support multiple wake words? And the short answer is yes. If you look at the, when I did the ModusToolbox kind of live demo, there was the two examples, the Picovoice one and the Porcupine one. If you go to that Porcupine one, it is actually a multiple wake word demo. So it shows, how you might go about doing multiple wake words at the same time. And it is one of our features, and kind of one of the cool things about it is it doesn't actually use very much more runtime resources, like in terms of CPU cycles or memory. The only real cost is the flash to store the model. So
I think it's we've just on the Infineon side, it's a really good feature because then you can actually load different models as well on the other side to go different directions. So you can expand the feature set by having different wake words. It's a really good feature.
Yeah.
Awesome. Well, thanks. And that brings us to the end of our hour. Perfect timing. And I just want to thank everybody for joining, all the panelists, all the people who came to the webinar. And as I mentioned earlier in the chat, we will be sending out a follow-up email to everyone who's registered with the recording link, as well as the slide decks. You'll get all of the links and everything that were shared during the webinar today. So thanks again, and we'll see you next time.